Hey there guys, what we're going to do is we're going to use this video to go through the answers to the electrolysis lab that you just got back. So we know electrolysis means we're using electricity to split something, because lysis means to split and electro means electricity. And the electricity that we're using is the power inside this battery. So this battery is going to do a lot for us. Before we even think about the observations that we had, we can use this battery to define anode and cathode for us, because the positive side of the battery is going to take electrons from whatever it's hooked up to, and the negative side of the battery is going to pump out electrons. So because electrons are going in, that means this has to be our anode, because we know electrons leave the anode and oxidation always happens at that electrode. Because electrons are coming into this electrode, that means we're having a gain of electrons over here, which means this is going to be the cathode, which is where our reduction is going to be occurring. So before we even think about our observations, we can define anode and cathode right away just based off of how it's hooked up to the battery. So now we can start to talk about what observations we saw as the reaction took place. At the cathode, when you investigated the electrode at the end, you noticed there was a solid orangey red color at the bottom. Now at the anode, we saw bubbles, which meant there was a gas produced. We also dipped in pH paper into this, and we dipped pH paper and we noticed that it turned a pH of 1 or 2, which meant also at this electrode we had to have some H pluses made. So we know the H pluses are there because the pH paper turned pink, which equals a pH of 1 or 2. So that meant we had to have some H pluses going around. So before we can even start to think about and conceptualize what the half reactions are, we have to first understand what we saw. Over here we saw some sort of solid form, which meant something in the solution had to be able to create a solid. The orange-red color gives us a hint that it was actually the copper. So what that means is at this cathode, these copper ions were taking in electrons to become solid copper. So this is actually solid copper. So now we can write our reduction half reaction as our aqueous ions taking in the 2 electrons to turn into solid copper. So now we need to start thinking about what's happening over here. We know the other ion we have in solution is the sulfate ion. But when I look at the products, this sulfate ion really has no way to make H+. So this guy is actually a spectator and he's not doing anything. So now we have to think about what else is in this solution. And because it's aqueous, that means that there's water present. So what must have been happening at this electrode is water must have been going to the electrode, dropping off electrons, making H+ ions, and also making bubbles. So now we have to figure out, if I make H+ ions, what gas does that mean I can make? And when you look at your reduction potentials chart, what you'll notice is that when water is making H+, that leaves behind oxygen to form a gas. So that gas is actually going to be O2. So now we can write our oxidation half reaction as our water molecules turning into acidic H+ ions and O2 gas. And now we just balance so we know how many electrons we need to put in. Because I'm making O2, this must have a 2 in front, which means that's going to be 4 H pluses, which means this is also going to make 4 electrons. So this would be my my oxidation half reaction. So when I think about combining these things into an overall reaction, because this is losing 4 electrons and this only wants to gain 2, I then have to multiply this whole thing by 2 so my electrons cancel. So my overall reaction is going to be water, that's liquid, plus 2 copper sulfates, because sulfate's going to be my spectator ion I add back in. That's going to turn into 2 solid coppers plus 4, or sorry, not 4, plus 2 H2SO4s. And I know it's H2SO4 because SO4 is my spectator ion. I've got acidic H's that are on the product side of this reaction. So since SO4 is 2 minus, that means I've got 2 H's for it. So 2 H2SO4s gives me my 4 H pluses, my 2 SO4s. 2 here, and a 2 here, and a 2 here. And then I also have my oxygen gas as a product. So this would be my overall reaction. So now we have to calculate E cell. Oh, that was terrible handwriting. Let's try that again, guys. Sorry. Now remember, E cell is always the reduction potential for your reduction times the reduction potential of your oxidation. I'm sorry, minus the reduction potential of your oxidation. So this is where we're going to go ahead and we're going to look at that reduction potential chart. So my E cell is going to equal my reduction, which is my copper guy over here. So I'm going to find him on the table. And that would be, oh, I took a terrible picture. So that'd be 0.3419. And from that, I'm going to subtract my oxidation, which is going to be, bear with me for a second, I need to find it, because of course I don't have this ready in advance. Why would I do that at Nair? I mean, come on. Oh, there it is. Duh. Minus, oh, and I can't see it now, 1.229. So when I do that in my calculator, you'll notice I'm going to get a negative number. So if I do 0.3419 minus 1.229, I end up with negative 0.8871 volts. Whenever you do the E cell for an electrolytic cell, it should be negative because we're using the battery to drive the electron movement. So this is a non-spontaneous thing, which means I should get a negative cell reaction. So this is the answer for the part 1. So let's go ahead and let's do the answer for part 2 now. So if we think about some of the observations we had, we put Na2SO4 solution into this guy. What we started to notice is that the anode, our universal indicator, turned red. And at the cathode, my universal indicator turned purple. So we know from our acid-base chapter that universal indicator turning purple means we have to have OH minus present. We know that red means acidic. So I know around this electrode I have to have H pluses made, which I'm going to draw down here. And I know around this electrode I have to have OH minuses made. The other observation we saw is we saw bubbles. Again. So we saw bubbles at this electrode. And we saw bubbles at this electrode. So if we think about this reaction, I know I've got H pluses and OH minuses. Neither of these things can make H plus or OH minus. So this Na2SO4 is not doing anything for the actual oxidation and reduction. We'll talk about what he's important for in a second. What we have going on is we have water being split. Because we can have water come into this electrode like we saw in the last reaction. It can come out and make 4 H pluses and O2 gas. At this electrode, it can come in, kick out OH minuses, but in this example, this is going to be H2 gas. Because the positive side of the battery is here. This is our anode. So this is where oxidation is happening, so our electrons are coming in. The negative side of the battery is pumping out electrons, which means this is going to be our cathode. So this is going to be where our reduction takes place. The anode half reaction for this is no different than the one above. So we're going to have 2 waters. Oh, that's interesting. I don't know why that just happened. That's fun for everybody. So our 2 waters are going to create 4 H pluses and 4 electrons. That was fun. I like when random things just show up in the middle of the video. Here, our waters are going to make OH minus and H2 gas. So now we have to go ahead and we have to balance. So we put a 2 here and a 2 here, so our O's are all balanced. I'm -2, so I put 2 electrons into this guy here. So because this guy kicks out 4 and this guy kicks out 2, I'm going to have to multiply this guy by 2 when I do my overall cell reaction. Now because we've got H pluses and OH minuses, those are going to combine to make waters. We've got some electrons that are going to cancel, so when you're at the very end of this reaction, what your overall reaction is simply going to be is H2O going to 2H2 plus O2 gas. So this is our overall reaction. So now we can go ahead and we can calculate our E cell. Our E cell is again going to be the anode minus the cathode. So I'm going to look up in the textbook, and this number is not going to be any different than it was in the first one. So it's going to be that same number that I, of course, forgot. So it's going to be the, I could just go up on the next page and look, I guess, because, you know, that would be too simple for me. Oh, yeah, I'm going to do that real quick. Whoop, whoop. So it's going to be the 0.3419. And now I'm going to look for the E cell in the textbook of this reaction, my water making my OH minus ions, which of course is going to take me forever to find, let's be honest. Oh, nope, there it is. Oh, nope, I just closed the picture out. I apologize, you can all make fun of me. This is quite hilarious right now. Oh, my bad. This is not the right number. That's not the right number. I'm sorry. That number is the 0.1229. That's my anode. I put that in the wrong spot. So my cathode is going to be my 0.041. So when I do this in my calculator, I'm going to do my point. Oh, man, that is awesome writing by me. I'm going to do my 0.401 minus 1.229, and again, we will get a negative number. In this case, we're going to get negative 0.828. So again, it's negative because this is not a spontaneous thing. This is a non-spontaneous reaction. So why is the Na2SO4 in there? Why do we need that at all? The reason we need that Na2SO4 in there is because we know pure water will not conduct an electric current. So if I just have pure water and I hook up electric current to it, nothing's going to happen. So the purpose of the Na2SO4 is to allow the water to conduct in order. That is awesome handwriting. For the electrolysis to occur. So these are just our spectator ions. They're not doing anything. They're not being excised, not being reduced. They're just allowing the electric current to pass. That's their only purpose in this whole lab. So what you guys have for homework is you guys are going to be drawing a picture for part 3. Some of you guys will have this picture. Some of you guys will be doing it just on a piece of notebook paper, a piece of computer paper, and you will be turning it in. You have accessible to you the lab rubric that I've passed back so you guys know how you're going to be graded, and all the requirements are on the back side of this picture that you guys have. So I've given you kind of a description of what we would have done in the lab had we actually done this. We would be electroplating a nickel, but we are not going to be doing that piece. We're simply going to be drawing a picture that would represent what would happen. There are notes about this, and it's also covered in your textbook, but this is individual. This is to be done on your own. It will be turned in tomorrow, and I will be grading that. So now that you're done with the video, you can take your homework up to the sub to show them that you have it done, pick up a homework answer key, and start checking your homework answers. When you're done with that, you can either draw this picture on your own, you can work on the review sheet that I've given the sub, or you can work on your lab final. But that's kind of what we got going on. If you've got any questions, guys, I'll be running a review session tonight on Google Hangouts on Air, so you can ask me questions then, or you can shoot me an email. I hope this helped. Talk to you soon, guys.